Just post in the chat if you can hear me and if you can see my screen share. If you can see my presentation, just let me know if everything is good. We're still waiting for a few more people. I think we'll start in a minute or two. Great, I'm seeing everybody. Everybody is able to see and hear at least. Okay, guys, I'm going to go ahead and start so long. Don't worry if you missed some of the parts of the presentation, or if you want to go through it again. We'll share the slides with you guys, as well as we'll load up the webinar onto our YouTube page, where you can go view it again. And if you would like, we could send it to you directly as well. Okay, let's go ahead and get started. Welcome, guys. Welcome to today's webinar, our Tech Hub webinar on M2I HMIs. We'll be mainly focusing on how to set up an HMI, specifically Modbus as well as Siemens as well. And then we'll do a brief demonstration at the end as well. Please post your questions in the chat if you want to ask a question or if you have a query of some sort. We'll try our best to answer during the presentation or at the end at least. So my co-host today is Brigitte Fafferot. She'll be allowing you guys in if I don't see you guys joining, or if you got disconnected or so on. All right, let's get started. So what are HMIs? We're going to look at why we need HMIs and where the need for HMIs actually came from. A brief introduction about HMIs, and then I'm going to introduce you to M2I's range of models, as well as their features, and then we'll specifically talk about the top design studio software used to program the HMIs as well. Then we'll look at the protocols supported by the HMIs and by the top design studio software. And then I'll go ahead to a live demonstration showing you how to create a project, how to link buttons to addresses on your PLC, etc. All right, so what are HMIs? To understand an HMI, we first need to look at where that came from, or where the need for an HMI came from. So HMIs in the history were basically dials, buttons, lights, and so on, displaying you information about a machine that you want to control. So you'll typically find physical buttons, physical LED lights, dials, displays, etc. And these were used to control the machine directly, right? Now, early machine controls were very basic, as you would typically only have a limited amount of control of your machine, depending on the amount of inputs and outputs you wire to these specific buttons and dials and so on. The operators can only see outputs or inputs or control inputs to their machine with the physical buttons and controls available on these control panels. Now that limits the amount of information that the operator would have. Let's say, for instance, the machine won't start, you would typically only have one fault light. So you wouldn't be able to easily see what is wrong with the machine. You would then need to go and do fault finding, and this could be a very long and tedious process. As well as each button and light and dial and gauge needed to be hardwired to your controller or even to the devices directly or to your relays, etc. And this would mean that there's a lot of wiring involved. You would need extra input or output cards on your PLC, which increase the size of your PLC panel, which in turn then drives up the cost of that control system. And the more information the operator would need to control the machine, the more buttons and lights and stuff you need to add to these control panels, adding complexity and increasing cost as well. So that's why we need HMIs, because HMIs give us a lot more flexibility in designing our control system to control our machines or plants. So HMI stands for a human-machine interface. It's an instrument used to view and control a machine's behavior. So with that, we can literally represent the plant as it is before you, with all the tanks and controls and motors and valves on a display, which allows us to give us greater control of our machine and gives us more insight into what the machine is doing, how it's operating, and what types of errors and stuff that we are seeing. So the screens that the HMI displays are developed using special software. Like I said, with M2I, we use the Top Design Studio. And HMIs also give us extra capabilities, such as alarm logging, trends, and other unique features, which gives us greater control of our machine and shortens the time to do fault finding when things go wrong. HMIs also give us greater flexibility when it comes to control, because if we want to add another input or a sensor that we've incorporated into our control system, we can easily do that without the need to wire an extra wire from our PLC as an output to our control panel. We could simply add another button or display on our HMI, making it much more flexible. So let's take a look at the range of M2I's HMIs and the specific range of models. M2I has developed a whole range, all the way from a economical range up to more like a advanced or feature-rich range. So let's take a look at the top R series. These units come with a detachable display and process unit. So the process unit is separate from the display unit, meaning if something goes wrong with the display or the control unit or the process unit, those could be easily replaced. They come with quad-core CPUs, meaning it's got a lot of processing power, aluminium body or chassis, and multi-touch support. With the premium models, you get an integrated camera, and I'll show you some features that can be incorporated with that camera as well. Proximity sensors for dimming the display when no one is around or no one is operating the display. Video input for if you want to incorporate a camera system into your HMI. Audio output for audible alarms or playing a sound. And then also HDMI output to take your HMI display and display it onto a large format display. A QR code scanning can be implemented with the top R series, and also remote monitoring using VNC, as well as multi-layer support for objects, screen call, and 16 or 1.6 million colors for high quality graphics as well. Now the top R comes in two variants, a premium or a standard variant. And here's a description of the display unit's model name. So you would find a top RD 1520X, for example, and 20 being a premium model or 10 being a standard model. And then you've also got a model number for your process unit. So that would be top RP, and then your type of model, standard or premium, and then a type of input that you would have with that unit. The resolution is specified by X. So as you can see here with the 1520X, that's a premium model that would have a higher display resolution. And the S versions have a 800 by 600 display resolution. Now, what's nice about the top R series is the detachable display and process units, meaning you can easily replace the screen if the screen is faulty or got damaged somehow during in the plant, making maintenance much easier and faster. A smart sensor built into the screen for energy saving purposes, so it can recognize when the operator is close by, then bringing up a brighter display so that the operator can operate the machine using the HMI. Very nice about the top R series is a compatibility with various types of devices. So you can, it's a USB host, you can incorporate a barcode printer or a mouse and keyboard, Ethernet and serial interfaces for connecting to controllers, server drives, etc., or PLCs, audio outputs for headsets or speakers, video input for cameras or CCTV, as I said, HDMI output, and also field bus capabilities like BACnet, CAN Open, and EtherCAT. Now, just a brief overview of the differences between the premium and the standard version. So the premium version is the only one that comes with HDMI output, video input, audio output, field bus connections, and also an optional Wi-Fi capability. The standard unit comes with normal Ethernet, serial, as well as the USB host incorporated in the unit. The QR codes sensing adds the ability to identify, let's say, an operator that has specific rights on the PLC, on the HMI. So let's say, for example, a manager comes, he scans his QR code, you would be able to set points and do a lot more than an operator typically would be able to do. So operator would only be able to start or stop the machine, etc., where a manager can actually change parameters, for example. And this can be done by generating a QR code in the Top Design Studio, printing it out, and then can be printed on an ID card, which you can then present to the HMI's front integrated screen, and it can allow that user to log in using that QR code. Like I said, the HDMI output allows a user to easily connect a large format display so everybody can see what's going on with that specific machine on a larger display. Now let's take a look at the Top RH series, high performance wireless chipset, also quad-core CPU for higher performance, and it comes with an optional cradle to charge the HMI, and it's got an anti-impact bumper guard, a 7-inch high resolution LCD display, IP65 waterproofing, and it also comes with VNC and FTP support. Again, multi-layer object support and multi-screen functions with a 16 million color display. Then we get the Top RH with the e-stop. This is specifically for controlling, let's say, overhead crane, for example. This could be a good application for HMI like this. It comes with a quad-core CPU as well, ergonomic design with a hand grip, selectable options such as a key lock, emergency stop, and grip function, as well as the high-resolution LCD display, waterproofing, VNC, multi-layer objects, screen functions, and multi-screen function, and also the 16 million color display. Now, this device does not come with wireless, as it is a device that has the emergency stop capability, which is not recommended to send an e-stop over a Wi-Fi connection. Then we get to the Top RW series. It's a new series from the X-Top's bestseller, but comes with a wide format display. It's reasonable price to performance ratio, making it very economical type of HMI. Also supports a quad-core CPU with a 800 by 480 resolution in 10, 7, and 5-inch variants. Also has VNC support, remote data transfer using FTP, as well as multi-layer structure of objects. And then we get to our top RX series, more of a mid-range HMI. These HMIs, let's take a look at the back part of the HMI. So we've got a silicon gasket for impact buffering, as well as IP proofing for panel mounting. Power communication and status LEDs are also at the back, so that you can see where the communication is working, your device is powered, as well as the CPU status. They come with a variety of communication ports. Depending on the model you choose, would depend on how many COM ports and Ethernet ports the device has. Typically, they come with 2 COM ports and 1 Ethernet port, but it depends on the size of the unit. So COM1 and COM2 both are DB9 connectors with RS232, 422, and 485 support, and these are software selectable, so no dip switches needing to be changed there. A 10 base T or 100 base TX Ethernet connection with auto NDI-X, and a USB type A connector for storage or external device connections such as barcode scanners, etc. Power input terminal supports 24-volt DC input. Then also at the back is a cover for an SD card reader for data logging and software updates, a mode switch to select system setup mode, a reset switch to reset the device to factory default, as well as a manufacturer connector for diagnosis. Then when we go to the front, we'll see a TFT color panel LCD, analog touch panel, front cover for dust and damp proofing, and then also a micro USB port in the front to upload or download your HMI program. The Top RX also comes with a quad-core CPU for higher performance. So that means it's got the same performance as the Top R range. Redefined integrated body design. So this model does not have a detachable processing unit. It's an all-in-one unit. Each different network interface supported from the 10-inch model. We can also incorporate the VNC functionality, multi-layer support of objects, the multi-screen screen call function, as well as 1.6 million colors. Now again, just the description of the device model name, the Top RX, that's the model series. The size of the display, 12 in this example. Derivative models, what type of network interfaces you'll have, and then also your resolution would be determined by the X or S version. And then also DC input as standard. So in this model, we get all the way from a 5.6 inch all the way up to a 15 inch, and they all support different resolutions. So a lower resolution on the VD, 800 by 600 on the S, and then 1024 by 800 for the XDs. Now, the quad-core CPU, what does that mean? It gives us greater stability when we want to control our process. With a quad-core CPU, each process can be divided per core, meaning calculation, graphics, PLC communication, logging and alarms, etc. Can be handled by different cores. And this means that you would be able to have greater performance out of your HMI. These HMIs also support various multimedia functions, like importing images such as JPEG, bitmaps, portable network graphics, and even vector graphics into your HMI for drawing your pictures, etc. Videos can be used or uploaded to the HMI, maybe for tutorials on how to use certain functions, etc., as well as a PDF view, which allows you to upload, let's say, for example, a manual on how to use or how to fault find certain alarms. So these HMIs also come with a unique scripting function using JavaScript, and they also have a wide range of predefined examples or samples that you can use in the HMI to perform specific functions during the HMI process or during the control process, meaning you would not be needed to send specific information to your PLC, for example. You can directly control or use JavaScript to process certain values in your program. Now, the HMIs also support a multi-screen monitoring function. This means you can call up or display all the displays on your HMI on a single screen. And these screens are live, so you would be able to see when errors occur on a specified screen, and then you can click on that screen to open up that screen and show you more information or show you the bigger screen so that you can do maintenance on your machine or perform a set point value, change a set point value, etc. Makes it much easier and nicer to do a screen call function. One of the very unique features, very nice features about the M2I series is the VNC support. So VNC is like remote desktop, but it allows you to control and monitor your HMIs through the VNC client. So VNC can be installed on multiple devices. It can be installed on Android and Apple devices, as well as Windows PCs, also Linux PCs, which means you can then, in the office environment, let's say, for example, your HMI is at the machine, next to the machine, and you want to be able to see what's going on, you can log in via VNC from your office computer and then monitor the system and control the system as well. You can also do a top-to-top VNC, which allows you to connect from one HMI to another using this VNC functionality. Obviously, with any HMI, you would need some sort of security options, be able to lock out certain parameters from the operator so that your operators can't change certain set point values, for example, during the process. But with the ID and passport security function, you can add the security parameter to an object to allow just managers or supervisors to be able to change certain values or turn on certain pumps, etc. Now, with the vector graphics that's incorporated with the HMI, it comes with a large library of vector graphics, which can be used to draw up your plant or your process pictures. And these vector graphics are very high quality, and each section of that vector graphic can be changed according to your needs. So each part of the vector shape can be changed to show a different color, for example, during the process. Now, the machine can also, or the HMIs can also handle multiple projects at a time. So you can load more than one project on a single HMI, which gives you the ability to load up different projects for different machines, for example, or different processes. Another unique feature or nice feature about M2I's HMIs is the temporary lock. which allows you to set up a temporary lock function to lock out any operation of the HMI during, let's say, maintenance, where people are working on the motors or drives or valves. You could then set a temporary lock, which allows you to temporarily create a new user with a password, and this would lock out any operation on the HMI. Like I said, we can incorporate PDF, video, and text, or images for guidance. Let's say for you've got a specific alarm, you don't know how to handle that error, you can go ahead and load up a guide on how to fault find that type of alarm. Email sending by appointed account under set conditions. So you could set conditions or alarms, specific alarms, to email a specific recipient. This can be done either by direct input, so you could type your own little message in the alarm setup, or you could use a text table which can be used to trigger from a specific event like an alarm or a specific error that came to be during the process. As well as this SMS functionality. The SMS functionality can be done by using a SMS service like Twilio, for example. You could send SMSs quite easily from the HMI also. Now let's take a look at the Top Design Studio software, which is the software that we use to design our HMI interface and connect our buttons and controls to our PLCs or controllers. So Top Design Studio comes with a user-friendly design interface to create custom and unique HMI control screens, scripting capabilities with predefined examples to allow users to easily create custom scripts for control, beautiful vector graphics for accurate plant representation, multiple PLC protocol support, and we'll take a look at the different vendors of PLC manufacturers that M2I supports, alarming functionality built in for easy alarm building, logging and trending to store historical data for later analysis as well. And these logs can also be exported using the USB or the SD card reader in the HMI. Let's take a look at all the industrial protocols supported by the HMI. I'm not going to go through all of them. There is a very large list of HMI or PLC manufacturer support. As you can see, a whole list of Mitsubishi PLCs are supported over here, as well as M2I protocol support. Again, continued with the list for Mitsubishi PLCs, Omron PLCs, and their supported protocols. Again, Modbus support, Modbus RTU, TCP, Siemens support with S7300, 400 series, and using the Open Communication Protocol. Again, Siemens continued S7200 series using PPI, 12 or 1500 using the Open Communication Protocols, Rockwell Automation, Panasonic, Yaskawa, Yokogawa, Schneider Electric, RS Automation, Hitachi, Delta. As you can see, the list just goes on and on and on. Now with M2I, this is the biggest list of supported protocols from an HMI vendor that I've ever seen. Honeywell, just to give you a few examples. Again, some IUSONG, a whole lot of protocol support. And this, I believe, is the last one. You could also create custom protocols with this HMI. So it's very flexible with connecting to controllers. Now, let's dive into our live demonstration. I'm going to be connecting to an Modbus device, but I'll quickly show you how to connect to a Siemens device as well. So let's start off by going to my desktop first. Just going to minimize that. So to start a new project, we first must open our Top Design Studio software. And this is the software that we use to design our HMI screens, connect our buttons and controls, and set up our logs and alarms. And then we download this program that we've created to our physical HMI. Now, with the software, you could also simulate the PLC project, the HMI project, using the offline simulator as well as an online simulator, which is used when you want to connect directly to your controller as well. So to start off, I'm going to start with a new project. I'm going to click New Project, and then you'll see a list of models that you can select. Now, what's nice about the Top Design Studio is it supports all the top series of HMIs. Now, if you are familiar with our previous range, the X-Top series, these programs can be converted to a Top Design Studio project and be downloaded to a newer range HMI if you need to replace an older X-Top type HMI. So in our example, I'm going to be using a Top RX series device, and I have a Top 800S, Top RX 0800S. So as you can see, it will show me the resolution, the size of the display, the color bit mapping, and the amount of memory in that HMI. You could also select whether you want the HMI to be landscape or portrait. In my example, I'm just going to use landscape. Then you click Next. Now you need to set up your communication settings. You could skip this step, but it's normally recommended to incorporate or add your PLCs as you go through this wizard, because it just makes things easier. So I'm going to add an Ethernet device. In my example, I'm going to use a Modbus Master Series to add a slave device to my HMI. I'm going to click Next. And then it's going to ask me a little bit more information, what alias I want to give it. I'm using a E22. I'm just going to call it iLogic. It's Ethernet based. And I could select, if there were other protocols supported, I could select another protocol here. And then I specify the IP address, the port number, etc., using the options over here. So I'm going to select my IP address over here. I'm using Modbus TCP. I'm using the default port, default timeout, and I'm going to leave everything else on default. Now, with some controllers start with a zero-base addressing scheme, which means you start with address 0. Other controllers use a one-base addressing scheme, meaning you start with address 1. So I'm going to leave that on default as well. And then you click OK, and it will add that PLC to your project. Now, what's really nice about the M2I series of HMIs is the fact that you can add multiple PLCs to the same HMI. So the HMI actually supports multiple protocols simultaneously. So I could select a Siemens PLC, for example. As you can see, the Open Communication Protocol, and I could program a Siemens PLC controller as well. And then select the series that I want to connect to, and I click OK. And both these devices are Ethernet based. So my HMI connected to a networking switch, and then from that networking switch going through your network to your various PLCs. So you can control multiple systems using the same HMI. Once I'm done adding all the PLCs that I want to add to my project, I can go ahead and click Finish, and it will open up my design page for this HMI. Now, to start off, I'm going to build a master screen first. So master screen is the screen that would always be displayed. It's like a backdrop to the rest of the HMI. So let's say, for example, this type of screen would be used for displaying alarms, as well as the date and time, the user that's logged in, and also your navigation buttons to navigate between screens. So what I'm going to do is I'm going to simply add a new object. So I go to the Object tab and I click on a bit lamp. The bit lamp is a bit type input. I double click on that bit lamp. Now you could use static colors, or you could use the built-in library of images. So if I click on the image icon over here, I could go ahead and select which images I want to add for that specific bit lamp. And as you can see, there's a wide range of available vector graphics that I can use. So I'm going to go ahead to this ellipse type button, and now I can select the button I want to use. Let's say, for example, I want to use this one. I could click on that one, and it will add that button to my off and on image. Sorry, I want to swap them. So as an off image, I'm going to leave it like that. So once I've done that, I can click OK, and it will add my off and on type button to my lamp selection here. Now, for this button to do anything, I need to add an effect to that button. So the condition is what triggers the button to change shape or change its color, and what condition actually affects the action that I want that button to do. So in this example, we want a touch event to affect the action. So I leave the condition as a touch event type, and now I can go ahead to my action. Now you see there's no action added to this button at the moment. Now I could select a special function for this, and I could say, okay, I want to do a screen change, and I want to use screen number 1. I want to open up screen number 1 when I press this button. Once I've done that, I can go ahead and click add, and that would add the effect or the action to that button. Then I click OK, and then my button is added to my screen. Now to change something on the button, you can just double click on that button. I forgot to add a text into my button. So I select the text option, use text, and let's call this main screen. And there we go. Now I can copy that button and paste it to add a second button. And I can add and change the effect so that it opens up a different screen, for example. Let's say screen number 2. Let's rename that button. Let's call it screen 2. Screen 2, and I click OK. Now in this menu over here on your screen menu, so you've got a project window, which gives you all the functionality available for this HMI, and then you've got your screen manager window, which allows you to add screens, modify your master screen, and modify your base screens. Now to use that master screen for your base screens, you need to go to the properties of your base screen, and you need to select this option, use master screen. Click OK, and you would see that I can't edit those buttons in this edit window, but they are displayed, so I can see where those buttons are, so I don't put anything on top of them. Okay, you can add new screens. You can give it a new screen number. Now, as you've seen in the previous section, where on the master screen where I added the second button, I selected this button to open up screen 2. So this screen 2 is very important. This number is very important so that you can call the right screen when you add new screens. Okay. And there's my second screen. Now again, to have the master screen on the screen, I need to enable that checkbox. And there it is. Okay. Okay, so let's go ahead to our first screen. And now I'm going to go add another object. Let's say, for example, I want to add a graph or a gauge. I go to the graph section under my objects tab, and I select a gauge, for example. Now it would open up when I click on the screen. Once I've selected gauge and I click on the screen, I can now edit this gauge to be displayed differently. So it could either be a linear type gauge or it could be a secular type gauge. Now, as you can see, this gauge is quite plain. I want it to look a bit nicer. I could go ahead to the background, select image, and then click on this image browsing button over here to add a new gauge type image. And then I can select whatever background for that gauge I want to use. Let's say I want to use the one with the different colors for the different levels. And it would add that background to my gauge. Now, let's say, for example, I don't want to use a background. I can use a plain gauge as well, or I could change the gauge wall to be an image as well. Now you'll see this looks much nicer when I do it this way. Let's select a different one. And there you go. You've added a gauge to your HMI screen. Now we need to link this gauge to a specific value that it's going to read from our HMI. So we go ahead to data and we select the data source for our specific gauge. So in this example, we're going to use a 30,000 register, which is a holding register. And I'm going to click OK and OK again. And this will now display the input value from that PLC. Now, as you can imagine, if you've got multiple gauges, buttons, etc., linking them one by one with a specific address in your PLC or your controller can be quite tedious. So I just want to take you through creating a tag or a symbol. So you can come to your project tab or your project manager window, and then go to symbols and double click on that. Then we add a group. So we want to say IO logic inputs, for example. And in that group, I could now add a symbol. I could say, okay, this is analog input 00, and the address is 30,000. Now you see, if you click on this little calculator icon, it makes it much easier to address your values. So you could select a 0 register, which is a coil, input register, holding register, and got the last one. Anyway, so you could select the specific register. This is for Modbus. You could select the specific register for that PLC. Now, if I select PLC2, you would see that the address names would change. So with Siemens, you would typically use an input word, an output word, or a marker word, or even a direct DB connection, so a DB word, for example. And you can then address those addresses directly from the HMI. Now, in my example, I'm going to use the iLogic 30,000 register 30,001, for example. And then this would now allow me to tag or give a symbol to this specific address. I click add. Once I'm done, it would now address that input address from my PLC or my controller to that tag name. And I can hit apply, and it will apply those settings. What's really nice about this is the fact that you can now, you just add one address, and then you can export that group. And it will save it as a CSV file. Let's call it test. And now I can go ahead and open up that CSV file in Excel. And as you can see, it's given the group name, iLogic inputs, the symbol name, and the address. And now I can use this to generate my tags for my HMI project, making it much faster and easier to incorporate all the values that I want to read out of my PLC. And then once you're done editing your Excel project or Excel spreadsheet, you can go ahead and import that specific CSV file into your project, and it will add all those tags that you've created for those addresses. And then you can use those tags in your PLC program, in your HMI program. And as you can see, it already made that analog input value available for me from that symbol. And I can use that symbol then to read my values out of my PLC. Now, to add a log, to add an historical trend. So trending is typically used when you want to see, let's say, temperature value or humidity, etc. You could add that trend directly from the input or from a tag, but that would not be historical. So you won't be able to go back and see previous values. It will only show you a real-time trend. So to add an historical trend, we first need to add a log. So I've added my table or my trend, but now let's go to log first and then add a log to my project. So first we need to select the address that we want to log. So we could either say I want to log as that symbol, or I want to log the address directly. So I want to log the second analog input. Okay. Now the log count, this determines how big the log is. So how many logs will it generate from that address? Let's say, for example, 1000. And I could add that to my project, and it will start logging that value or those values. Now the condition for the log is when it should start logging. So you could say, I wanted to log every 10 milliseconds, or every 100 milliseconds, or every second. Let's make it every second. Okay. And then you can select whether you want to back up that log onto an SD card, and if you want to use a specific condition to log that backup. And then use data set. We could edit this and select none, which would then mean that data set would always run. And you could also specify which date condition and time condition you want to read. You could either use an input or an output from the PLC itself, or you could use special addresses within the HMI as well, like the date and time, for example. Okay, then you hit apply. It would apply those settings, and then you can close. And now you could use the trend that you've incorporated in your screen to then use that log that we've created to trend the log. So our specific data that we want to use, we can then select the log to log specifically or to trend specifically that log. Once you've done editing your screens and changing your HMI screens, I'm just going to copy this trend to another screen so we can see when it changes. We need to save our project. So after you've done editing, you can go ahead and save our project. I'm just going to call it new project, save it on my desktop. And now we go ahead to transfer or trans. Now in the trans section, we have a multiple options like the offline simulator, the online simulator, full build and transfer, just screen transfer, make build file, transfer project file, upload data. So first, let's start with the offline simulator. And this would open up a new screen showing us our actual HMI screen. And if we click on our buttons here, which we've set to navigate between screen 1 and screen 2, we can see that it actually navigates between those two screens. Okay. What's really nice about the simulator as well is the fact that you can simulate the data that you want to be displayed. So let's say, for example, I want to simulate whatever needs to be displayed on the gauge. Just use the right address, and there you see the gauge is simulating the value that I've entered for the address that's addressed to that gauge. A very nice feature for testing your HMI project, testing your scripts, testing your alarms and logs, etc., to make sure that everything is working correctly. Then you can also do an online simulator. This would actually connect your HMI or this Top Design Studio to the physical controllers that you've connected to it or connected to your PC. And this would allow you then to test your HMI project with your actual PLC. So it will allow you to run this simulation for 2 hours. And currently there are no inputs on my iLogic. I don't have an analog sensor here. So currently it's displaying 0. If there were an error with the PLC communication, that would also be displayed on this display. And then you can go ahead and exit. Now to transfer your file to your HMI, you first need to build the project. So you do a full build and transfer. This will test the project and make sure that all your scripts and addressing and everything is done correctly. And then it will do an OS check once you start the process of sending the file to your HMI. Okay, You can transfer the file either using Ethernet or the built-in USB micro USB connector in the front of the HMI. I'm going to do this by using the Ethernet option. So first I need to go ahead and search for my HMI, make sure I can find it. And there we go. It's showing my model name, the OS version, Hydra version, Daemon version, etc. And also my IP settings. And it will show that I'm connected, and I can go ahead and click OK. And now it will say transfer is ready. So first it checks whether the OS from the HMI is compatible with the Top Design Studio. What's nice about Top Design Studio is they incorporated the fact that when you want to, when you updated your version of Top Design Studio, it also updates the operating system version on the HMI itself. So you don't have to manually update the operating system when you want to, when you're using a newer version of the software. Once you've done that click, it will allow you to send your project to the HMI. Okay, and it would say transfer success, and you would be done with your project. I'm just waiting for it to start up. Once you've downloaded your HMI project, the HMI will restart, and it will allow you to run the program. Now, I want to show you a very nice feature. I've got the VNC client installed on my laptop already. So this will allow me to connect to the HMI. This will be an unencrypted connection, which is fine. I've got no password set up. And this is what you'll see. This is what I'm actually seeing on the screen on the HMI right now. So this is currently what's being displayed. I was just checking whether the VNC server is running, and it is. And I can go ahead and close these control panels, and you can edit these settings on the HMI as well. So you can go ahead into your menu, and you can change the HMI IP address. You can check the comms with your PLC as well. If I click on that PLC, I could select the PLC and then do a ping test, for example, to test whether I have got communication with my PLC. Can also do a diagnostic to see if communication is okay. Now I can go ahead and run. And you would see that the project that I've loaded on the HMI is the one I've just created. Now you see I've changed the screens on the HMI using the touch panel on the HMI, and they're also changed on the VNC viewer here as well. So a very nice feature if you want to remotely monitor and control your HMI. You can disable the controlling feature for the VNC as well, which makes it great for just viewing purposes as well. All right, that's my story, guys. If you've got any questions, I don't know. I'm seeing a lot of questions here. Let me see. Okay. Okay, all good. Rob says top RW is our most popular HMI. Yes. I'm not 100% sure what, I think it stands for video network connection or virtual network computing. There we go. Thank you, Jan. It comes from Korea. Yes, thank you, France. The Top Design Studio is absolutely free. Thank you, Rob. Yes, guys, you can go ahead to M2I's website. I've got it open here. You can register on their website for free and then download all of their software for free. There's also some very nice communication manuals which allow you to, which describe how to connect to specific PLCs, for example. I meant to show you something, guys. Connecting to a Siemens PLC, in this example, a CPU 1212, you would be required to use a block like this, the open user communication block. I have done this. It's a little bit complicated, but if you need any more information on how to get that working, I'm sure we can talk. Just give us a shout if you need more information on that. Right, let's see. Okay, we'll share the download links for you. Top Design Studio, yes. Okay, Brigitte will sort you out on pricing. Yes, that is 2 hours total per session, so it will stop allowing you to control the HMI or control the controller with the online simulation, and then you would then be required to restart. Okay. Yes, so if you want to indefinitely run the software from a PC, you would be required to buy a license. And Rob says the license is for SCADA view, SCADA top view, but the HMI software is free, so you can use the software to develop and design your HMIs and load them on your HMIs. You don't have to buy a license when you buy an HMI, but when you want to run the software from a PC, you would need a license of some sort. Yes. Any more questions, guys?
I just mentioned, can you hear me, Johan?
Yes, yes, I can hear you.
The licenses are only for the SCADA, which is the top view. That's the SCADA developer. What's great about this product is that you can use the HMI software, so it's the Design Studio, to develop your HMI and at the same time develop your SCADA. So it's the same software that you can make use of. And the licenses start with the 100 tags and go up to unlimited tags. So that 2 hour you're seeing there is because it's not seeing the dongle installed, the USB dongle is not installed, so it's not seeing the SCADA license. So if you want to develop a SCADA or an HMI, or you want to transfer your HMI software into a SCADA, it's as easy as then buying your tag count and making use of it as a SCADA.
Yes.
This information, you have a 100 tag, a 300 tag, a 600 tag, a 1,300 tag, a 2,000 tag, as well as a unlimited tag. And if you ask Brigitte, she will be able to give you pricing on the SCADA software. So you don't need it to do your development. Thank you.
Yes, absolutely. Thank you, Rob. All the same communication protocols that are supported with the HMIs are supported with the top view SCADA as well. Like Rob said, we use the same design software to design both the top view SCADA as well as the HMI screens. With alarming and events, can additional PLC variable be included in an event? I'm not 100% sure what you mean by additional PLC variable. Maybe you can just elaborate a bit.
Let's take that question offline, and maybe we can
All right.
send the customer the answer.
Henny, just take my email address. I think you can, yes. I think you can. I'll have a look at that. Just drop me a mail and I'll look at that setting for you, and then we can chat about it in greater detail. Is that okay? Great.
Do we support ABB PLCs? Yes, we do.
Okay.
Maybe show the PLC again.
Let's go to our Ethernet-based, add a PLC. Let's just have a look here. They're not listed in alphabetical order. If I'm not mistaken, ABB supports Modbus. So you could use Modbus directly. Anyway, I don't see ABB in the list here, but we can have a look at that. Any more questions, guys? You're more than welcome to unmute.
Johan, I think, did you see the message from Wasim?
No.
What communication protocol does
Yes, I did answer that. So
okay.
The Top Design Studio is used for both the Top View SCADA as well as the HMI development. So all the protocols supported by the HMIs are also supported by the SCADA, the Top View SCADA as well.
And then there's one question here from Kitiku. He's saying, okay, so I can use my iLogics with the HMI with no license needed.
Yes, absolutely. Absolutely. We have applications like that. Many customers of ours actually use our HMIs in conjunction with the iLogic series, as well as now with the iThings series. That would also be possible, 100%.
Thanks, Johan.
No problem.
We can also use the HMI with the previous controllers too, by the way.
Oh yes, of course. With previous controllers, with iThings, iLogic, all of them would be supported, yes. The HMI has an inbuilt PLC in it? No, not really. It only has the scripting function, which allows you a bit of scripting capability to run certain scripts to do certain calculations or certain things for you. But it's not a fully fledged PLC built into the HMI, no. Okay, guys. So what's next? Join us on Thursday, the 30th of April. I'm going to show you some exciting new ways of programming using Node-RED. I'm not sure if some of you are familiar with Node-RED, a very dynamic, flexible piece of software, all open source, meaning we can develop our own code, our own nodes, etc. And it's a very nice to use little tool, especially with in conjunction with devices like our UC series, which is based on Debian 9. Node-RED fits in very nicely with those types of devices. And I'll be showing you how to create a program and how to connect to cloud services, etc. For remote data logging, as well as remote control, possibly as well. So stay tuned, join us for our next session. We hope to see you there. And thank you so very much for your time. Remember, guys, here's our contact information. If you need quotes, if you need need to contact our accounts department, as well as some technical support issues, don't hesitate to contact us. we are available. Thank you for watching, guys, and we hope to see you soon, and have a good one.